A reagent which increases the oxidation number of an element in another reactant is called oxidizing agent. If an element in its lowest possible oxidation state in a compound, the compound can function as reducing agent. Redox reaction, in which chemical compounds are formed by the combination of two or more elements, is called combination reaction. Example: combustion of carbon, combustion of methane. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today I am going to start session 3 from the chapter Redox reactions. We have discussed that what is oxidation number or what is oxidation state, and also rules for assigning oxidation numbers. How to assign oxidation number for given compound and how you have to follow with rules. Okay, these are the two contents we have discussed in the previous session. In today's session, we will discuss about definitions of oxidizing agent and reducing agent in terms of oxidation number. We know what is oxidizing agent and reducing agent, but today we will discuss in terms of oxidation number. So, little bit its statement will be changed. Types of redox reaction and balancing of redox reaction. Okay. What are the kinds of redox reaction also we will discuss, and also balancing of redox reaction. There are two kinds of balancing of redox reaction, but in today's session we will discuss the first method of balancing the redox reaction. So, these are the contents which we will discuss in today's session. Definitions of oxidizing agent and reducing agent in terms of oxidation number. The reactant that reduces an element in another reactant is called reducing agent. In terms of oxidation number, what they are telling? The reactant that reduces an element in another reactant is called reducing agent. The reducing agent contains the element that is oxidized. Whatever it has been oxidized, that will be called it as reducing agent. Okay. Whatever the reducing agent contains, that will be oxidized. But what is the function of reducing agent? Any element or any reactant that reduces an element in another reactant. So, that another reactant will be get oxidized. Okay. The reactant that oxidizes an element in another reactant is called oxidizing agent. If it is reduces, reducing agent. If it is oxidizes, oxidizing agent. The oxidizing agent contains the element that is reduced. This part will be reduced, will be little bit changed. Okay. Next, reducing agent. A reagent which decreases the oxidation number of an element in another reactant is called reducing agent. Any reagent which decreases or which reduces the oxidation number of an element in another reactant will be call it as reducing agent. The oxidation number of reducing agent is increased during redox reaction. The oxidation number of reducing agent will be increased, but in the reactant side it will be decreased. A reagent which increases the oxidation number of an element in another reactant is called oxidizing agent. If it is any reagent is increasing the oxidation number of another reactant is called oxidizing agent. The oxidation number of oxidizing agent is decreased during redox reaction. Once again I am telling, reducing agent means it will decreases the oxidation number of element in another reactant. Oxidizing agent means a reagent which increases the oxidation number of any element in another reactant will called oxidizing agent. Okay. This is about the definitions of oxidizing agent and reducing agent with respect to oxidation number. MnO4 minus, which is a oxidizing agent. Okay. Oxidation number decreases means reduction is going to happen. Mn2 plus, here you have to observe plus 7 will be getting decreased to plus 2. Here reducing agent if they have added means Fe2 plus, here plus 2 oxidation number is increased to plus 3. Okay. Here once again I am telling, oxidation number decreased means reduction, oxidation number increased means oxidation. Okay. This is the statements of oxidizing agent and reducing agent with respect to oxidation number. Here they have added oxidizing agent, reduction is going to happen. Here they have added reducing agent, oxidation is going to happen. Okay, little vice versa is present. So this is the best example to understand the definitions of reducing agent and oxidizing agent in terms of oxidation states. Next, tips for the identification of oxidizing and reducing agent. How you will identify the reducing and oxidizing agent? To analyze or to identify, they have given some of the simple tips. If an element is in its highest possible oxidation state, if an element is in the highest possible oxidation state in a compound, the compound can function as an oxidizing agent. Any element, if it is containing highest possible oxidation state, that element of a compound can act as oxidizing agent. KMnO4, this K2Cr2O7, HNO3, H2SO4, etc. Okay, here oxidation states will be more, +7 will be there, +5 will be there, again +5, like this. If an element in its lowest possible oxidation state in a compound, the compound can function as reducing agent. Like H2S, H2C2O4, this is oxalic acid, this is ferrous sulfate, etc. Here oxidation number will be less, that's why it will be considered as lowest possible oxidation number, so reducing agent. Next, if an element in its intermediate oxidation state in a compound, the compound can function both of an oxidizing agent as well as reducing agent, like H2O2, HNO2, SO2, etc. It is in intermediate state, not more or not increased possible oxidation state or not completely decreased possible oxidation state. It is in intermediate state, so that compound will be acting as both oxidizing agent and reducing agent. Also, if a highly electronegative element in its highest oxidation state in a compound, the compound can function as powerful oxidizing agent. Once again, if a highly electronegative element like halogens, chlorine, fluorine, iodine or oxygen, like that, if it is more highly electronegative element in its highest oxidation state, okay, in its highest oxidation, whatever the electronegative element is present, its highest oxidation state is along with its present, that compound will be acting as powerful oxidizing agent. If an electronegative element in its lowest possible oxidation state in a compound or in free state, it can act as powerful reducing agent. See here, I minus, Br minus, N3 minus, etc. This is the free state and having lowest possible oxidation state. Also it is electronegative element. So it will be acting as powerful reducing agent. These are the 5 tips which they have given to identify the oxidizing agent and reducing agent. Once again I am telling, if it is highest oxidation number is present, then it will be considered as oxidizing agent. If it is lowest oxidation number is present, then it will be considered as reducing agent. If it is in intermediate state, intermediate possible oxidation state is present, then it will be considered as oxidizing agent, also reducing agent. If the electronegative element with highly oxidation state is present, that is powerful oxidizing agent. If an electronegative element with lowest oxidation state is present, then it will be considered as powerful reducing agent. That can be present as free state also. So these are the 5 tips to identify the oxidizing and reducing agent. Next illustration, we will see one example. Justify that reaction to, that is copper oxide giving rise to copper oxide plus copper sulfide is giving rise to 6 copper sulfur dioxide is a redox reaction. Identify the species oxidized, reduced, which act as an oxidant and reductant. Here you have to identify which has been oxidized or reduced, or which is a oxidizing agent, oxidant, and which is a reducing agent, reductant. Let us assign oxidation number to each of the species in the reaction. Under examination, this results in 2. For given the reaction, you have to analyze each and every element with oxidation number or oxidation state. This one +1, this one -2. This is interchanging also you can do. And this is +1 and -2. This is 0. This is +4 and -2. In this reaction, copper is reduced, okay, because +1 to 0, so reduced, and sulfur is oxidized because -2 to +4. Hence, copper 1 is an oxidant and sulfur of copper sulfide is reductant. Okay, here +1 to 0, it has been reduced. It is an oxidizing agent, and here -2 to +4, it is a reducing agent where it has been increased. Okay, this is an illustration or example to identify the oxidizing agent or reducing agent. Here, types of redox reactions. Redox reactions are of several types: combination reaction, combination reaction, decomposition reaction, displacement redox reaction, and disproportionate reaction. We'll see one by one. First, combination reaction. As the name itself shows, combination reaction means two reactants should have to combine. Redox reaction, in which chemical compounds are formed by the combination of two or more elements, is called combination reaction. Example: combustion of carbon, combustion of methane. Combustion means oxygen, obviously it has to present. Carbon plus oxygen, carbon dioxide will form. Here 0 oxidation state, here also 0, but here it will form by oxidation +4, by reduction -2. Next, combustion of methane. Methane plus oxygen plus carbon dioxide gives carbon dioxide plus water. Here combustion of methane will takes place. Next, decomposition reaction. These are redox reactions in which chemical compounds undergo decomposition by itself or heating to give products containing at least one elemental state. One reactant, it has to be decomposes into two or more products. Okay. Here KClO3 having individual oxidation numbers. Here KCl plus 3O2 will form. Displacement redox reaction. These are redox reaction in which an atom or ion present in the chemical compound gets replaced by atom or ion of another element. Based on metal or non-metal involvement in the displacement redox reaction, it is classified into two types. Displacement means here see X plus YZ. Here Y is getting combined with XY plus Z. Okay. In that, two types: metal displacement reaction and non-metal displacement reaction. A metal in a compound can be displaced by another metal in the uncombined state is called metal displacement. Here copper and zinc. Zinc will be displaced with sulfate. Here non-metal, all alkali metals and some alkaline earth metals which are very good reductants will displace hydrogen from cold water. Completely non-metal displacement. Here sodium is a metal. Here sodium hydroxide will form, H2 will be liberated. All the types of reactions are common reactions, but here redox reactions will be seen. Less reactive metals such as magnesium and iron reacts with steam to produce dihydrogen gas. See here magnesium and water, magnesium hydroxide will form with hydrogen gas. Fluorine is so reactive that it attacks water and displaces the oxygen of water. Here see water with fluorine, HF and O2 will be liberated. Next, disproportionation reaction. It is a specific type of redox reaction in which a species is simultaneously reduced and oxidized to form two different products. This type of reaction is possibly only when an element can exist at least 3 oxidation states. The element in the form of reacting substance in the intermediate oxidation state and both higher and lower states of that element are formed in the reaction. Example, the decomposition of hydrogen peroxide is a familiar example of the reaction where experiences disproportionate. Here H2O2 will form H2O plus O2. Here the oxygen of hydrogen peroxide, this oxygen of hydrogen peroxide which is present in -1 oxidation state is converted into 0 oxidation state in O2 and decreases to -2 oxidation states in H2O. Okay, this is how the disproportionate will be seen or will be observed. Next, balancing of oxidation and reduction reaction means balancing of redox reaction. Two methods are used to balance chemical equations for redox processes, that is oxidation number method and ion electron method. These are the two methods to balance the redox reaction. In this session, we'll discuss oxidation number method. In the next session, we'll discuss about ion electron method. Now we'll discuss oxidation number method. Balancing redox reaction by oxidation number method was developed by Johnson. This method was developed by Johnson. What are the steps involved to balance this redox reaction by oxidation number method? We'll see now. Step 1. Write the skeletal equation. If not given, frame it of all the reactants and products of the reaction. If they have given in the reaction in a statement wise, you have to write its chemical equation and you have to write its reactants in the left hand side, products in the right hand side, and you have to, if it is not there, you have to frame that equation. That is a step 1. Step 2. Indicate the oxidation number of each element in the equation and identify the elements which undergo change in the oxidation number. After writing the skeletal chemical equation, you have to write each and every elemental oxidation number, and along with that you have to identify which element is undergoing change in its oxidation number. Sometimes you have seen copper in +2 in reactant side, in product side if it is going to +1 state. So there change in its oxidation state, not only writing the skeletal chemical equation, you have to analyze which element is undergoing its oxidation number changes. So that is step 1 and step 2. In step 3, calculate the increase or decrease in oxidation number per atom and identify the oxidizing and reducing agent. After analyzing which element is undergoing changes with respect to oxidation number, by analyzing that, immediately you have to find out which is oxidizing agent and which is reducing agent in that reaction. Step 4. Multiply the formula of the oxidizing and reducing agents by suitable integers so as to equalize the total increase or decrease in oxidation number. After getting oxidizing agent and reducing agent, multiply the formula of oxidizing agent and reducing agent. Usually how you will do the balancing of chemical equation, like that you have to multiply, trial and error method you have to do, and you have to equalize the number of atoms per compound with left hand side and in also right hand side. In step 5, balance the number of atoms other than oxygen and hydrogen atoms. In the reaction, usually hydrogen and oxygen will be present. If it is present, you have to first balance other than oxygen and hydrogen. First you should not balance with oxygen and hydrogen, you have to leave those two elements, you have to balance other than hydrogen and oxygen. Step 6, balance hydrogen and oxygen atoms by H2O molecules using hit and trial method. After analyzing other than oxygen and hydrogen elements in balancing, in step 6, you have to analyze or you have to balance hydrogen and oxygen by adding or by removing water molecules in the method of hit and trial method. Okay. Example, acidic and neutral solutions first balance oxygen atoms by adding H2O molecules to whatever side deficient in O atoms and then balance hydrogen atoms by adding H plus ions to whatever side deficient in hydrogen atoms. If the reaction whatever they have given, if it is in acidic medium or neutral medium, if oxygen is deficient, you have to add oxygen. How you will add? Then you have to add through adding water molecules. If hydrogen is less, then you have to add H plus ions wherever the hydrogen atoms is deficient. Okay. Next, for basic medium, the first balance of oxygen atoms by adding H2O molecules to whatever side deficient in oxygen, the hydrogen atoms are then by adding H2O molecules equal in number of to deficiency of hydrogen atoms and an equal number of OH minus ions are added to the opposite side of the equation. Here, if it is present in the basic medium, then for oxygen also you have to add H2O molecules. For hydrogen also you have to add H2O molecules. Later you have to add OH minus molecules. It should be in equal number in both the sides. Okay, these are the rules, set of rules you have to follow to balance the redox reaction in the method of oxidation number method. We will see one example. Balance the following redox reaction by oxidation number method. This is they have given. This is chromate, and this is sulfur trioxide, and this is chromium plus sulfur oxide plus water. This is in acid medium. First step, skeletal equation they have written here. Next step, assigning the oxidation number to each and every element. See here, for chromium +6, for oxygen -2, for sulfur +4, oxygen -2, and they have added H plus here and chromium 3+, for sulfur 6+, H2O molecule. Oxidation loss of 2 electrons because +4 to +6. So loss of 2 electrons, oxidation gain of 3 electrons because +6 to +3. Okay. Equalize the change in oxidation number of both the atoms by multiplying with suitable integers and balance the number of oxygen other than oxygen and hydrogen. This is the step where you will not balance the elements hydrogen and oxygen, other than that you have to do. See here, chromium, everything. Chromium they have added 2 Cr, okay, and here yes they have done for chromium. Other than that, for you have to leave about oxygen. For chromium they have added the integer. Okay. Next, add H plus and water to balance oxygen and hydrogen. They have added H plus also, they have added water also. After adding H plus and H2O, see here Cr2, 2 Cr, oxygen, here also oxygen 4 plus here, and hydrogen is also present, here also hydrogen is present in acid medium. Next, in balance the following redox reaction by oxidation number method. This is also in acid method. MnO2 plus bromine, Mn2 plus bromine plus H2O. This is also in acid method. Usually skeleton equation they have written, and oxidation number, loss of 1 electron, and this is gain of 2 electron. Equalizing by multiplying suitable integers, MnO2 plus 2Br, Mn2 plus Br2, add H plus and water to balance oxygen and hydrogen atoms in acidic medium. They have added 4 H plus and it has been balanced. Okay. These are the 2 examples to understand the oxidation number method which were used to balance redox reaction. In the next session, we will discuss half reaction method or ion electron method and application of redox reactions. These are the 2 contents which will be discussed in the next session. I hope you have understood completely whatever I have taught today. We will meet in the next session. Thank you.